You are listening to the AI World Podcast, your trusted source for the latest innovations, insights, and trends in artificial intelligence, blockchain, fintech, and decentralized technologies. Each episode features expert interviews, engaging discussions, and in-depth analysis of how AI transforms industries worldwide. Stay ahead of the curve with the latest articles and exclusive reports from the AI World Journal, covering everything from emerging technologies to industry breakthroughs. For more news, global events, and access to AI World Society circle gatherings, visit us at aiworld.tv. Don't forget to subscribe to stay informed, stay connected, and be part of the AI revolution with AI World Lounge. Thank you for listening.
Welcome to the Deep Dive. Today, we're going to take a shortcut, basically, into what's next in computing.
Yeah, we've got some great source material here.
We do. It outlines the 10, most important AI technologies right now. Not just buzzwords. These are the things actually shaping the tech landscape.
Definitely.
And our sources, they kind of confirm two things you probably already feel. First, AI is just everywhere.
Right.
I mean, the report joked about an AI update hitting the author's toothbrush.
Wouldn't surprise me, actually.
And second, things are moving so fast, keeping up feels like a full-time job. So our mission today is to, cut through that noise a bit.
That's exactly right. Look, if you want to talk strategy or investment or even just how to use this stuff, you need the right words, the right concept.
The vocabulary.
Precisely. AI isn't just one thing anymore. It's this huge, interconnected ecosystem. So we're going to dive into let's say, the technical blueprints to really understand the mechanisms, how they think, how they remember, and crucially, how they're being built to actually do things in the real world.
Right. Let's start there.
Right.
With the concept that's taking AI out of the chat window and, maybe into the virtual corner office, Agentic AI.
Yes, Agentic AI. This is where AI stops being just passive, waiting for you.
So what makes it agentic?
It's the eponemy. It's designed to pursue a goal, often a complex one, through this continuous loop.
A loop?
Yeah, the source is laid out clearly. It has to perceive its environment or maybe some data.
Okay, perceive.
Then reason about what action to take next.
Reason.
Then act on that decision.
Right.
And finally, observe the results of that action, which feeds back into the next cycle. It learns and adjusts.
Perceive, reason, act, observe.
Mm.
That cycle.
Well,
that sounds like the key difference, right?
it absolutely is. It makes the AI inherently goal-driven. So we're talking about systems that could, say, manage a whole customer service workflow or run a complex audit, potentially over hours or days.
Without someone constantly prompting it.
Exactly. And that's why this is the foundation for what people are starting to call digital coworkers.
Digital coworkers. Okay.
They're designed to execute real, meaningful tasks, not just answer questions.
Got it. But for complex goals, they need more than just basic logic. Which brings us to the next point. Large, specialized reasoning models, or LRMs, an evolution of LLMs.
Exactly. Your standard LLMs, they're amazing at fluency, right? Generating text that sounds natural instantly.
Yeah, incredibly so.
But when you need structured step-by-step thinking, like for engineering problems or financial analysis, maybe even scientific discovery, you need something more rigorous.
So LRMs think differently.
They do. They break problems down using these internal logical pathways. Almost like how a mathematician builds a proof, step by step.
Okay, I see. And the training data is different too, I gather.
Much stricter. They're not just fed the entire internet. They're trained on verifiable stuff. Math proofs, working code, things where correctness can actually be checked. Often using reinforcement learning to really nail that accuracy.
So it's about provable correctness, not just probable text.
Precisely. Sometimes you see an AI pause before giving a really structured answer. That might be an LRM running through those logical steps, making sure the answer isn't just plausible, but actually, correct. It shifts the focus from generation to reliable problem solving.
Okay, so we have AIs that can act on their own and reason logically, but how do they, remember stuff and connect to the real world? This is where the infrastructure comes in, starting with memory. Vector databases.
Ah, yes, vector databases. Yeah. These are absolutely fundamental to modern AI.
What fundamental?
Because they don't just store raw text or files like old databases. They store information as embedding.
Embeddings.
Right.
Those are the numerical representations we hear about.
Exactly. Long lists of numbers that capture the semantic meaning of the data, the essence of it.
So, like the example in the source, A picture of a mountain isn't just stored as mountain.jpg. The database holds numbers representing what the picture means. Colors, shapes, maybe even the feeling it evokes, its relation to other mountain pictures.
You've got it. It captures meaning numerically. And that unlocks semantic search.
Which means searching by concept, not just keywords.
Precisely. You can find text, audio, images, video based on what they're about, their conceptual similarity. It's vital for any kind of intelligent search or recommendation system today.
Okay, that makes sense for memory. Now, how do we connect that memory to the language models safely? That's Retrieval-Augmented Generation, RAG, right?
Yeah.
Keeping AI grounded.
Yes, RAG is incredibly practical. It basically stops the AI from just making things up or hallucinating, as they call it.
How does it do that?
It forces the model, before it generates an answer, to look up relevant information from a trusted external knowledge source, like giving the LLM access to your company's latest reports or a verified database.
So it's like an open book exam for the AI.
Kind of, yeah. The sources detail this neat three-step process. Your question gets turned into a vector.
Like we just discussed with vector databases.
Exactly. Then it searches the vector database for related trusted information.
And step 3.
It feeds that retrieved information back into the prompt it gives the language model, so the LLM generates its answer based on those retrieved facts.
So the result for you, the user, is answers that are actually contextually accurate and based on real data.
Huge benefit. Absolutely essential for things like research, legal tech, any corporate system where factual accuracy is non-negotiable. RAG turns AI from just creative to actually reliable.
Okay, reliable internal knowledge. Now, what about interacting with the outside world? If agentic AI is the digital coworker, it needs a way to, use other software. That's the Model Context Protocol, MCP.
That's the idea. Think of MCP as a standardized bridge or maybe like a universal translator for AI.
Bridge between what?
Between the AI model and, well, everything else.
Yeah.
Calendar, your email, databases, software APIs. Traditionally, you'd need a custom connection for each one. Very painful.
So MCP avoids all that custom integration work.
That's the goal. It defines a common language, a standard way for AIs to access and exchange context with other tools and data sources.
Makes engineering sense. Build one connector, not dozens.
Exactly. And think back to our agentic AI.
The digital coworker.
Right. MCP is what lets that agent actually do things. It could pull live sales data from one system via MCP, analyze it, then use MCP again to schedule a meeting in your calendar.
Okay, so it's the plumbing that makes a truly interconnected AI ecosystem possible. It lets the agents operate.
Precisely. It moves beyond just talking to actually doing.
All right, let's shift gears a bit. We've talked about capabilities. Now let's talk efficiency and scale. We always hear about how much power these giant AI models use. How are engineers tackling that? Mixture of experts or MOEs?
MOE is a really clever approach to that problem. Instead of having one single massive energy-hungry model trying to do everything,
Which sounds inefficient.
MOE divides the system into multiple, smaller, specialized neural networks, the experts.
Okay, like having specialists on a team.
Exactly, and there's a router mechanism that looks at the incoming task and activates only the most relevant expert or maybe a small group of experts.
So if it's a math problem, it routes to the math expert, not the poetry expert.
Pretty much. The big benefit is you're not firing up the entire enormous model for every single query. You only use the parts you need.
Which saves compute power.
Massively. And energy and money. Plus, often these specialized experts can actually provide higher quality results for their specific domain than a generalist model. So it's efficiency and quality.
Makes sense. Next up, expanding the AI's input beyond just text. Multimodal AI. This feels like giving AI senses.
It really is a huge step in that direction. Historically, AI was text in, text out mostly.
Right.
Multimodal systems can process and understand different types of data together. Text, images, audio, video, simultaneously.
So it can watch a video clip, read the transcript, look at related images, and understand the whole context.
Yes, or describe a photo you upload, analyze a chart within a document, even generate music based on a description. It's about integrating these different data streams.
And the benefit is?
A much more human-like understanding of context and nuance. Think about how we understand the world we see, we hear, we read.
Right, it's all connected.
Exactly. Giving AI multiple input types allows it to grasp relationships and meanings that are lost when you only look at one type of data. It bridges the gap between raw data and, well, richer understanding.
Okay. And finally in this section, where does all the training data come from? especially for tricky situations. The sources talk about synthetic data. Why make data up?
Well, sometimes real-world data just isn't good enough or safe enough.
How so?
You need huge amounts of data to train big models. Real data sets might be too small, or they might contain biases you don't want the AI to learn. Or, critically, they might contain sensitive private information, medical records, financial data.
Things you definitely can't just feed into a model?
Absolutely not. So, synthetic data is artificially generated data designed to mimic the characteristics of real-world data, but without the limitations or risks.
The sources mentioned simulating scenarios for self-driving cars.
Perfect example. You can generate millions of miles of virtual driving data, including rare edge cases like, sudden blizzard or a weird obstacle, much faster and safer than driving real cars for centuries.
Or generating anonymous patient data for rare diseases.
Exactly. It allows for risk, definitely. So optimizing compute isn't just about making models faster. It's about making them feasible, sustainable, and maybe even accessible beyond just the giant tech companies.
The sources mentioned specific techniques: quantization, pruning, low-rank adaptation. What do those mean in practice?
They're essentially smart ways to shrink the models without losing too much performance. Think of it like compressing a huge image file.
Okay.
Quantization, for instance, reduces the precision of the numbers used inside the model. Using simpler numbers takes up less space and energy. Pruning removes redundant connections within the neural network. They're all about making AI leaner and more efficient.
So smarter and more sustainable, making powerful AI cheaper to run.
That's the goal. It's critical for broadening access and managing the very real costs.
Which leads us perfectly to the final and maybe the most critical area: AI ethics, safety, and governance. This is about trust, isn't it?
It's the absolute cornerstone. As these systems get more powerful and more autonomous, especially like the Agentic AI we started with,
Right.
the questions about fairness, bias, transparency, accountability, they become central. We need frameworks to ensure AI operates responsibly and securely.
The sources highlighted things like explainable AI, XAI, understanding why an AI made a specific decision.
Crucial. If an AI denies someone a loan or makes a medical suggestion, you need to be able to understand the reasoning, not just accept a black box answer.
And also algorithmic fairness, making sure systems aren't biased, plus regulatory compliance.
It's all about managing risk. The sources warn, quite rightly I think, that the technology often moves faster than our ability to govern it.
A dangerous gap.
It can be. So building in safety, ethics, and clear governance from the start isn't just nice to have, it's essential for long-term adoption and avoiding. Well, futures nobody really wants. #outro.
Wow. Okay, that was quite a tour through the AI technology stack.
Okay.
We went from tiny numerical meanings in vector databases
Through structured reasoning in LRMs.
to autonomous agents coordinating tasks using MCP. These 10 technologies really show a clear direction towards, well, more adaptive, maybe even self-improving intelligence.
It's happening fast.
It really is.
Yeah.
And hopefully for you listening, whether you're setting company strategy, doing research, or just trying to figure out your tech budget, understanding these 10 concepts feels less optional now.
They're pretty much essential context for the next few years.
Yeah.
And, thinking about how these pieces connect, especially linking that agentic AI.
The digital coworker idea.
Right. Linking that with the model context protocol that lets it act on accountable systems. It raises a really fundamental question for the governance piece we just discussed.
Which is?
If an autonomous agent acting like a digital coworker uses MCP to, say, reallocate resources or approve a major change, and it makes a mistake or causes harm, where does the accountability lie?
Who's responsible when the agent acts on its own?
No. Exactly. Is it the developer, the company deploying it, the agent itself? That intersection of autonomous action, technical protocols, and legal or ethical responsibility. That's probably the central challenge we're going to be wrestling with for the next decade.
A provocative thought to leave us with. Thank you for that deep dive.
My pleasure.
The future of artificial intelligence is unfolding, and it's happening at AI World Week, the flagship global event for innovation, collaboration, and transformation. This flagship global AI event is designed to connect visionary leaders, trailblazing entrepreneurs, and influential thinkers to explore the endless possibilities of AI. Experience groundbreaking technology that redefines industries and inspires progress. Join thought-provoking discussions on ethical AI, digital equity, and the transformative role of technology in our world. build meaningful connections that catalyze innovation and drive impact. AI World Week is powered by AI World Society, a global movement dedicated to advancing AI responsibly and ensuring it serves humanity. Together, we're shaping a smarter, more inclusive, and equitable future. Continue your journey beyond the event with the AI World Journal, offering expert insights, in-depth analysis, and the latest trends shaping the AI landscape. This is your opportunity to lead, to innovate, and to transform the world with AI. AI World Week. We invite you to join us and embrace the AI revolution.